Hello everyone and welcome to my channel, Tuner on Security. In this video, I'm going to show you how to solve a General Skills CTF challenge from picoCTF 2021. The challenge is called Python Wrangling. I've summarized the most important information about the challenge on this slide. The task is to decrypt a flag by running a Python program. You'll also find the link to the challenge in the video description below. Let's jump into the challenge. Here we have the challenge. Python scripts are invoked kind of like programs in the terminal. Can you run this Python script using this password to get the flag? So let's download these files. Let's head over to the terminal and start VS Code. Here we have the Python script. Then we have the flag and the password. So let's try and run the script. Here we get some help with the usage, so we're supposed to execute it with -e or -d. I'm guessing for E for encryption and D for decryption, followed by file. So let's see. We want to decrypt. The name of the file was flag.txt.en. Then we need to enter the password. So let's just try it straight off with this password. Oops. Here we have retrieved the flag. So let's copy paste that into the submission box. Hooray, we earned 10 points and solved the challenge. So let's have a look at the Python program to try and understand this in a bit more detail. So first we're importing some libraries, the packages, and here we can see that we are doing something with base64, and we're using a cryptographic package named Fernet. We see the usage message, which we received when we didn't provide all the necessary parameters to run the Python program. So it tells us how to use this. We have some checks on the number of provided arguments. Then we have the encryption part of the script, where the user is prompted to enter a password. Then there's some encoding being done and encryption with Fernet. Then we move on to the decryption part of the program. Here we also have a check of the arguments and a prompt to provide a password. There's an encoding being done and the cryptographic function is executed. Here the decryption takes place and the data is written. Okay. So that's pretty much it for this program. Let's cover Fernet encryption in a bit more detail. Fernet is a symmetric encryption method, which means it uses the same key for encryption and decryption. It guarantees that the message encrypted using it cannot be manipulated or read without the key. So here's how it works. First we have key generation. Fernet uses a URL-safe base64 encoded 32-byte key. This key must be kept secret, as anyone with the key can create and read messages. Then we have the encryption. When encrypting data, Fernet generates a secure message that cannot be read or altered without the key. This encrypted message is known as a Fernet token. Finally, we have decryption. When decrypting a Fernet token, if successfully decrypted, you will receive the original plaintext as the result. Fernet verifies that the data has not been tampered with prior to returning it. Under the hood, Fernet uses AES in CBC mode with a 128-bit key for encryption and HMAC using SHA-256 for authentication. For each encryption, a random initialization vector is generated, so the ciphertext changes every time. This is for security reasons and cannot be changed. Fernet is part of the cryptography library for Python, which is developed by the Python Cryptographic Authority, PyCA. It's used in various real-world applications to secure data. One example is Apache Airflow, which uses Fernet to encrypt passwords. Fernet is a cryptographic system that ensures that unauthenticated bytes are not exposed. However, the entire message content must fit in the available memory. As a result, Fernet is not suitable for encrypting very large files. If you want to learn more about Fernet, I put some links to further information in the video description below. If you have any questions or feedback, please feel free to add a comment below. And don't forget to like and subscribe if you enjoyed this video. Stay tuned for more videos on CTFs and other security-related topics. Thanks for watching, and I'll see you next time.